Hello and welcome to Maths Plus. Today we're covering functions. The standard is the Untitled higher level and leavingcert ordinary level. So there's a range of questions in this video grind which will cover quadratic graphs, exponential graphs, and the roots with decimals, which I'll use the minus b formula to solve. So the first question here is that we have three quadratic graphs. We have an expression up here and we need to find which graph matches the expression. So first of all, let's factorize the expression and let's do the work to solve the equation. Alright, so let's see. So we have x squared minus x minus 2. So along this axis here, okay, we need to solve for the roots. So let's see which ones match up. So to do this, we can factorize. So the x minus 2 by x plus 1 will equal 0 for the solution. And let's look at each factor. So x minus 2 is equal to 0. Therefore, x is equal to plus 2. And x is equal to minus 1 for the second. For this one, when I bring the 1 across. Okay, so these two match. The 2 and the minus 1. Okay, the 2 and the minus 1. It doesn't match part C. So that one can be taken out of it. Okay, so let's see the other aspect. Well, the number where x is equal to 0, the input of x is equal to 0, would be the value then. The f of x then would be f of 0 would be 0 squared minus 0 minus 2. So f of 0 is equal to minus 2. That will give a c value or a y-intercept of minus 2. So therefore that would match the first graph A. So therefore, in summary, if the roots are solved with the factoring and then subbing 0 in instead of x to find the y-intercept, we can be certain that the 3 points it crosses over are minus 1 and plus 2 for roots and minus 2 for the c value. Okay, so let's have another look. So we can choose graph A. So I always recommend to work out as much as you can, okay, and all the workings are really being tested in the question. So our first impression would be maybe to make a guess or something like that, but we need the information to make the decision. So work everything out, and remember, you can work out the roots by solving with the algebra, just factoring, setting the two factors to 0, and also then you can check then the y-intercept. If the graph is inverted, well, it would be minus x squared. Okay, and that's also another consideration. Okay, let's have a look at another function. So first of all, now we're just going to look at quadratic functions for a while. So I want to break it down into 3 main steps. So we're going to have the roots, we're going to have the factors, okay, and we know the output is actually an equation, so we just call it just the equation. Usually it's f of x or y. Okay. So the roots are the crossover points, and they're really the most valuable values we can have in our system. So let's choose two whole numbers. Let's go through an example. We could choose +4 and -2. Alright, so we're at this stage now, okay? So we're at the roots. Okay, so when we're doing algebra, usually we have an unknown, so we're going to call each of those x. So x is equal to -2, x is equal to +4. This is usually our solution when we're factoring. So in one sense, we're working in reverse. Now let's see how we can convert these two to factors. Well, in the second last line of solving, remember, we bring the number across. So if we bring it back, okay, for instance, we could go x plus 2 is equal to 0. So we could bring it back and we could go x plus 2 is equal to 0 is a factor. Okay, that's this one. Okay, move back. And what about the +4? Well, bring over the 4 and we can go x minus 4 is equal to 0. Okay, so we have everything we need now to form the equation. So the two factors multiplied by each other as such. Okay, so notice that the values for the roots will always have opposite signs inside the bracket. So let's look at those. That's a -2. It's converted to a plus. And let's look at the other, +4. So we could go directly, if you don't want to kind of set them up with the equal 0, you could go directly to part 3. Alright, so finally we just need to multiply everything out. So if we do a really quick multiplication here, we'll have x squared, and the cross multipliers will be +2x, and then multiply back -4x, and then -4 by +2 is going to give -8. Okay, and then finally f of x is equal to x squared minus 2x minus 8. Okay, so this graph will go through those points. It's positive. If we want to invert it, we could go minus f of x, multiply everything by -1, okay, and it would look like this. So we go through the same roots, okay, the same roots. This -8 then would become +8 up here, okay, so that would be minus x up here. Alright, so there are the three basic parts. So to recap here, the roots are the values where the quadratic crosses over the axis. Set x equal to both of those, bring them across, put them in brackets, okay, put them in brackets here, and then we can multiply them out to get the equation, and that does the trick. Okay, I hope that clears everything up. So let's go on to the next one. Alright, so sometimes you'll get an equation which will state solve to so many decimal places, or surd form. Surd form is another option. Surds. Okay, surds will have the root, could be root a or something. Okay, so if we were factoring, we would never really come up with the actual solution by trial and error, because it's too difficult to work out manually. Therefore, we need a formula. Okay, and the formula, what we have for factoring and finding a solution to a quadratic is the -b formula. Okay, this may seem familiar, but I'm just going to go through some tips of why we use it, and also a very, very competent way of putting it together. So we will not get any errors with the calculator. It's very important to do it in a very orderly manner. Okay, so let's write out the formula. So x is equal to -b plus or minus the square root of b squared minus 4ac over 2a. This is all you need. Alright, so all we need to do now is to correspond the a, which is the coefficient of the x squared, and the b is the coefficient of the x, and the c. Okay, we got to correspond them to the original equation here. Okay, and then we've got to substitute them in accurately and then do the plus and minus, because we'll have two roots for each quadratic. So let's put it all together. This is a very, very important stage now. Okay, so a is the number up here, so a is equal to 1. Okay, it's not x or x squared, it's the number before the x squared, which is the coefficient. So a is x squared because it's 1x squared. So let's look at another one. The b is going to be minus 4. So be very careful not to choose plus 4, because that will give us another position on the coordinate frame, and we need to get the exact sign. And the c then is minus 7. Okay, that's pretty obvious. Again, take the negative number. Okay, that would be the main source of error in these. Okay, so let's put it all together. So anybody familiar with my tutoring, they will know that I always say use the brackets. Okay, so let's put it all together. So minus b will be minus 4, plus or minus, and then we will have the minus 4 squared minus 4ac by 1 by minus 7 all over 2a, so 2 by 1. Okay, at this stage do a double check. Does everything look good? Let's do that. So we have the minus 4, we have the minus 4 here. Okay, everything looks good. The 1, the minus 7, and also the 1 down here. And our minus is up here. We have everything in place. Okay, so let's do all this in the calculator. So what we're going to get, we can do it all in one go, but I'm just going to do it out in stages here. So it's going to be 4 outside here, plus or minus, let's see what's in the square root. It has to be positive. Okay, so if we don't put the brackets around the minus 4 squared, we may end up with problems there and get an error. So we get 16. So in the square root, we're going to get 44. Okay. Over 2. 44 is also 2 square root 11. Okay, so let's work this out. So I advise you get your calculator and work it out as we go. So for the plus, I'm getting 5.316. So that 16 will push the 16 up to 20, and the 2 decimal place will be 5.32. The 316 will go to 32. Okay, and let's look at that's the plus. Let's look at the minus. Okay, so insert the minus here with your calculator. Okay, let's work out this together. So we get minus 1.316, and again to 2 decimal places, x is equal to minus 1.32. Okay, so we have it all answered. So I hope this was very detailed so that you get them right all the time. Okay, there's absolutely no room for error. Okay, if you do it in this manner, practice it at least once and you'll have a really good formula to put it together. Okay, let's go on to the next one. Alright, so what we're going to do now is just practice getting the A, B and C out of different combinations. Okay, so let's start off with these. It's always good to practice that skill. So x squared plus x minus 12. And we'll just go a, b, and c over here. Okay, the next one is 2x squared minus x plus 7. And then finally, minus x squared minus 2x plus 1. Okay, so try these now and pause the video and see if you get them correct. Okay, so let's see. So in the first one, we're going to get 1 for the A, 1 for the B, and minus 12 for the C. So if you got those, you're fully right. The next one is 2 for the A, minus 1 for the B, and 7 plus 7 then for the C. And finally then we have a minus 1. You see, minus x squared is minus 1. Minus 1x squared. Minus 2 for the B. And plus 1 then for the C. So I really hope you got them right, because if you get them right at the start, usually everything will follow on perfectly then with the formula, and then using brackets and double checking everything. Okay, let's carry on. Alright, so now we have a table here. We can see a progression. Okay, this one's a nice question just to introduce the exponential functions. So we have a table. It shows the number of layers for each of the 6 folds. So for each layer, okay, you can see when the fold occurs, then we'll have double the number of layers of the previous number. Okay, so for one fold we have 2, for two folds we'll have 4 layers, so onwards. So we can project that the 2 by 8 will be 16, and the 2 by 16 will be 32, and again 2 by 32 is 64. Okay, that's pretty easy. Okay, so let's look at the next part. So list the domain and the range. Okay, so the domain are the inputs. Okay, it's really like we're used to putting them along the x-axis in the graphs. Domain. So they're kind of going over and back. And in the range then are they're going to be, you know, the values, okay, which are a set of output values, you know. Okay, so we could do this in a table with the calculator if you set up the function, but all we have here now are the actual values, okay, and the formula y is equal to 2x. Okay, so the power is changing, okay, power keeps changing, and the base number is 2. So that's the number we observed, which is going to be multiplied out. So all we have to do here is just sub in our numbers 1, 2, 3, 4, 5, 6, and the keyword here is corresponding. So for 1, okay, the range value would be 2, okay, and onwards, 2, 4, 8, 16, 32, and 64. It's very straightforward. So we have really stated that the domain are the input values and the range are the output values. Okay, and we can have 2 separate sets. Okay, so part C now. Work out the least number of folds which would require more than 500 layers. Okay, so the output must be in excess. So the range has to be greater. The range value has to be greater than 500. And we want to find the corresponding domain value, or the x value for that. So all we have to do is keep going. So let's keep going. So if we go to 7, so I'm just going to do 7 to 6, and then that will go up to 1 to 8. Okay, what about the 8? We'll multiply 1 to 8 by 2, and we will get 2, 5, 6. Okay, and it's getting closer now. So on the 9th fold, we will get a result of 512. Okay, 512 layers. So therefore, the number x will be 9. And as you know, that's the domain, and that the 512 is the range value. Okay, that was nice and straightforward, and that's called an exponential function, and the base was 2. Okay, so we have quadratic functions and exponential functions, both different. All right, so let's look at some other exponential functions. Exponential. Okay, exponent is the power. All right, so I'm just going to do two examples. One what everybody's familiar with, and that's 10 to the power of x. 10 to the power of x. So when x is equal to 1, our output will be 10. When x is equal to 2, our output will be x to the power of 2, which is 100. So you can see already the pattern that an extra 0 is being added on to our range value. What about x to the power of 6? Well, that would be 1 million. 1 by 1 million. 1, 2, 3, 4, 5, 6. So we plot those, and if it goes up really high, really quickly, it's exponential. X to the power of 0 is actually 1, or 10 to the power of 0 is 1. Okay, because that's a log rule. Okay, and that's an exponential function. So the base is 10. Base is equal to 10. Okay, so just sketch one more. Okay, I think you probably following this perfectly now. But let's look at another one. And this is going to be the exponential function. So e is equal to 2.714. This is what everybody talks about when something is increasing exponentially, like COVID. Okay, so e to the 1 is up like 2.71. So it'll be up at e. Okay, and then for instance, if we go up to e to the 6, what value would that approximate? So if you get your calculator, you'll see this box called e to the x, or e to the box. So let's substitute in 6. So e to the 6 is 403. So sub in 6, go up and out, and we will get 403.4. 403.4. Okay, so it goes up really fast. Not as fast as the 10 to the power of x, but it does go up, and that's the natural reoccurring number, and we call it exponential growth. Okay, so I hope that makes sense. We have a graph of 2 to the x. This is a past unit question. Let's do this really quickly. So I'm just going to write in the values here. So set up your table like this. If you're using a calculator, just go to this setup, go to mode, table. Okay, input your f of x. So you go f of x is equal to, so in this case it's 2 to the power of x. So we're going to have to use the alpha. So do alpha alpha, and then go 2, and then a x button goes up there. Press equals, then fill in your table, and you will get an output of all these values. Okay, so let's start off with -2 over here. So for the domain, let's call them domain and range. Okay, x and y. Okay, so let's start off at -2, and we will get a result of 1 over 4. Okay, -1, we will get a result of 1 over 2. 0, we will get a result of 1. 1, we will get a result of 2. And then +2, we will get a result of +4, because 2 to the power of 2 is 4. Okay, so if we plot these, we will get an exponential function like this. Okay, so we're starting off at a positive value, so plus 4. So for minus 2, we're just above the line, just above there. Okay, so then it's not going below the x-axis. You can see none of the values are below the x-axis. So minus 1 up to a half, so it's pushing up there. Then it crosses over at the 1. So 0, 1 is on the y-axis, and again y, 1 and up to then. So it should be a curve, and you can see from the previous graphs it's exponential when it looks like that. Okay, so that's a past Untitled question. You can do it in your calculator, get your set of outputs. Okay, so finally what we're just going to do is do a recap. What did we have today? Well, let's look at the questions. Well, we had the quadratic type equation, so we could factorize, and also we got the y-intercept. Okay, this helped us to find the roots, okay, and then it gave us so x1, y1 for the factorizing, and then the c value for the intercepts. Okay, that helped us solve the first question. Then we did a lot of work on the minus b formula. Very, very important. Okay, use your brackets, and don't lose your time, okay, when you see work it out to so many decimal places. You'll notice the minus b formula. And finally then, we did the exponential type functions. We did 2 to the power of x. We did 10 to the x. We did a problem with a table and also a calculator one. So finally, we did e to the x as well, the natural log. So all of this should create a very clear picture of functions, what they look like, the different types of functions for linear and quadratic. Okay, so if you found this helpful, this mini grind, then please like and subscribe to the channel, because if you keep coming back to the channel, you will learn more and more each day, and your capability will go much, much higher in the maths. Thank you for joining Maths Plus.